Stanford University.
Okay, well, welcome to lecture 15 of CS193P. Today I'm going to finish the demo from last time, and then I'm going to kind of introduce some miscellaneous topics here. And I'll be doing a demo for all of these things. And I'll do them kind of as I go because I'm not sure how much time we're going to have today. And if we run out of time, I'll just continue in the next lecture. So I'll kind of do slides and then demo, slides and demo. So here's the topics I'm going to do today. Text fields and text views, which is editable text. So you already know about UI label, which is displayed text. And so now I'm going to talk about editable text. Modal view controllers is yet another way to put a view controller's view on the screen. So far you know about navigation controllers, tab bar controllers, split view controllers, popovers. You can put view controllers' views on screen in all those ways. So this is another way, which is to put up a view modally, okay, in a mode where you can't do anything else but do what this view does and then move on. Next, I'm going to talk about UI view animation. So there's some things you can change about a view and about the view hierarchy that can be animated. Okay, pretty powerful system, very easy to use. All the animation is done by another layer, which we're not going to talk about in this class, called core animation, but there's a nice high-level UI view API for it, and we'll talk about that. And then finally, I'm going to talk about a framework called core motion. Core motion is the way that you're going to get sensory input from the accelerometer and gyro, if the device has a gyro. And so we'll talk about that. All right, so first let's finish up this Shutterbug demo. Last time with the Shutterbug map, we had the thing where we got the annotations by loading the information from Flickr into our core data and then just turning the photographer subclass of in this managed object. We turned that into an MK annotation. We made sure it implemented that protocol. And so here, let's run the app as it stood back then, just to remind ourselves where we are. So Shutterbug map, and let's run it here. All right, so we have our list table view of photographers, but we can also switch to a map, and then we get all of the photographers' locations. We used kind of a representative photo. We just grabbed a random photo from that photographer, and when we clicked on it, we got this call-out view. And it had the title. Title is one of the methods in MK annotation. And then it also had this detail disclosure button, which we wired up to do the same thing as when we click in a table view, okay? Which is to show the photographs from that place, from that photographer rather, not place. So what we're going to do today is just enhance this so that this call-out accessory on the left also shows a thumbnail of the representative photo. Okay, and that way as you're clicking around, you remember, oh yeah, that photographer took that photo. Oh yeah, so it's kind of a reminder thing for you. So I just want to show you a little bit how to do essentially a left accessory view. Okay, so the first thing we need to do to have a left accessory view is back in our photographer table view controller, which is where we are right here. You'll remember there's this method view for annotation, which is very much like table views. Give me a table view cell for row. Right, this is giving me a view for an annotation. Normally, in fact, pretty much always, we would want to use the DQ mechanism, just like we do in table view cell. I didn't for expedience sake, although when I post this code, I will put the DQ code in there just so you have it for reference how the DQ code works. But it's exactly the same. It looks exactly the same as a table view. But here I'm just going to continue for time reasons here, and I'm just going to create the left call-out accessory view. So you can see on the line above the cursor here, I'm creating the right call-out accessory view. So I'm just going to say aview.left call-out accessory view. And in this case, I want to display an image there, so I need a UI image view. So I'm going to say UI image view, alloc, init with frame, because I don't have the image yet to display. I'm going to dispatch off a thread to go do that. So I'm just going to do init with frame. And, I want a size image view that's going to look good in that call out. So I might have to play around with the size I want, a really tiny one or maybe a bigger one, which would make the call out, I want it to fit in that call out space. So I'm going to say, I happen to know that 0, 0, 30, 30 is a pretty good size. It's 30 pixels or 30 points by 30 points, which is not bad. And also, I am going to auto-release this. because when I assign it to be the left callout accessory view, I don't need to keep a pointer to it anymore. When I want to get it again to put the image on there, I'm going to just get that left callout accessory view. I'm going to see if it's an image view, and if it is, then I can set its image. All right? So that's that. So when are we loading up this image? I only really want to load that image. I only want to do the flicker fetch if the person actually clicks on the pin and make the call out comes up, right? Because otherwise, when I put all those annotations in there, it could be hundreds of them, I'm downloading hundreds of images. Even if I'm doing another thread, it's probably a lot of wasted work because the user is not going to click on the vast majority of those pins. So really, when the user clicks on a pin, that's when I want to go and do this download thing. So where does that happen? Well, there's a delegate method in map view. It's called map view did select annotation view. Okay, and so this gets called whenever an annotation view, and remember the annotation view is the thing that draws the pin, it's also the thing that puts the call out up. Anytime one of those gets selected, this gets called in the map views delegate. So what I'm going to do in here is I need a couple of things. First of all, I need the photographer in question for that pin. I also need that image view so that I can set the image in it. So the first thing I'm going to do is a little bit of introspection. So here's a review of introspection. So I need the photographer and I need UI image view. Okay, so I'm going to get those by doing some introspection and seeing if I can find them. If I can't find them, I'm not going to do anything in this method. Okay, that makes this method a little more flexible. If I change something about my left callout accessory view or something like that, then it won't do anything, but it also won't crash or anything like that. So I'm just going to say if the accessory view annotation is a photographer, right? Then my photographer equals photographer star aview.annotation. Okay, so this is an accessory view getting clicked. Remember annotation view being clicked. All annotation views have an annotation as a property, so I'm just getting that annotation. It should be a photographer, right? Because we put a bunch of photographers in there. We made it implement MK annotation, but I'm just making sure that it's photographer. And similarly, I'm going to ask for the accessory view's left callout accessory view and see if that is a UI image view, which it should be because, I set it to the left callout accessory, but if I change my left callout accessories or some of the annotations have a left callout accessory view and some don't, then this will be a little more robust. Then my image view equals UI image view aview.left callout accessory view. Okay, so you can see how I'm using introspection here. Just be a little bit more robust, but also I'm avoiding keeping an extra instance variable or some other data structure that keeps track of all my image views. That would be a pain in the neck too, right? So I'm kind of getting the best of both worlds here. I'm being robust, but I'm also not having to have these extra data structures. So now I'm just going to say if the photographer is not nil and the image view is not nil, then let's go update that image view for this photographer. And I'm going to do that in a thread. First, I'm going to grab the thumbnail URL from the photographer. Actually, I'm going to grab it from one of its representative photos. Okay, everyone cool what I'm doing here? Thumbnail URL. So I just asked the photographer, give me a representative photo. You'll remember we implemented that method last time. It just gives any object out of the set of photos this photographer has taken. So now I have that. And now I'm going to, if that thumbnail URL is set, I suppose it could be possible that either the photographer has no photos or that representative photo has no thumbnail URL. So if it is set, then I'm going to dispatch Q T, and I'm going to call this downloader, which is dispatch Q create, and I'll call it map view downloader or something. Again, this is just for me to see in the debugger and other tools. And this is always null. So now I have a queue to dispatch onto, so I'm just going to immediately dispatch async onto that queue. and I'm going to put a block. Okay, so this is all stuff you should be, familiar with, having just done this all in your homework in multiple places. So what am I going to do in this thing? Well, first thing I'm going to do is do that download, and I'm actually also going to create the UI image. Okay, so I'm going to say UI image equals UI image with data, and then I'm going to do the Flickr fetch here, which is image data for URL, thumbnail URL. Yeah, so there's that. Now, what's interesting here, some of you might be saying, wait a second, UI image, that's part of UIKit. You're doing this call, image with data, in another thread. This is not the main thread, right? Downloader is just some random thread I created. And the answer is yes, but there are some things in UIKit that are thread safe. UI image is one of them. Okay? Also, UI color and UI font are thread safe, and the core graphics stuff you can do in this thread as well if you're like drawing to an off-screen bitmap or something like that. So there are some things that are thread safe, and they'll be documented hopefully in the documentation, but UI image is one of them. So here I've kind of used that to my advantage where I've both done the download and created the image in this offline thread, and I still haven't bothered the main queue, but now I need to bother the main queue. So I'm going to say dispatch async again, this time back to the main queue. Get main queue. And all I'm going to do in that main queue is take that image view and set its image to be this image. Okay? Now, some of you might be a little concerned here, as well you should be if you really understood your homework from last time, which is we don't have any reuse here. I'm not doing the DQ thing on these annotation views, but what if I did someday? I could have a problem here where that image view, that left callout accessory view, got reused, and now it's being used for some other annotation view. Does everyone understand? See, okay, good. I see nodding head. So that was intentional in your homework, that hopefully you understood that was going on in your table view, that your cells could have been getting reused out from under you, because you have to imagine this Flickr fetch could take like 20 seconds. You might be on a 3G network and it's just like taking forever. And meanwhile, users clicked on 17 other annotation views looking around. Now they're not seeing any thumbnails because you're slow network, but they're still clicking around. Your main queue is happily active, and by the time this thread returns and tries to dispatch the main queue, it could be no good. So how would I deal with that in this case? There's a lot of ways to do that. One thing, I still have my A view, right? The accessory view that had this. I could check its annotation to see if it's still the annotation that this thumbnail URL came out. So I could kind of check that, and if not, just do nothing. In other words, just throw away that download. So there's a lot of things to do. Now here, I'm not doing the DQ. So I'm just going to leave this like this because time constraints. Again, I want to show you a lot of stuff today, but I just want to make sure you're aware of what could be going on there. And then the last thing I need to do, of course, is release my downloader queue so that I don't leak it. And let's see, we have okay, what is my error here? Accessing on, okay. So we need some imports up here. Let's make sure we import photo. Oops. And what is the other one? A Flickr fetcher, of course. Flickr fetcher. Okay, so that's what's happening down here. It doesn't know about photo, so it doesn't know about thumbnail or URL. All right, so there we go. So let's run this and see if this will work. Okay. All right, so here we have our thing. Let's go to our map. And hopefully when we click on one of these, there we go, we got a thumbnail. Okay, and you can see we're on a good network, the thumbnail. Oh, there's a good one where it didn't come up right away, but then when the downloader finally came up, it showed it, right? Meanwhile, it leaves space for it because I made that interview be 30 by 30. Now, these are so fast. I'm glad we had one nice slow one. You can see how it loads. But so anyway, does that make sense? Everyone got that thumbnail thing? Okay, that's all I really wanted to show you there. Okay, so let's talk about text fields and text views. So like I said, UI text field as opposed to UI text view, that is just like UI label, or very similar to UI label, but it's editable. Now, one thing to think about here, though, is, and the reason I haven't talked about it all the way until lecture 15 here, is that entering text on the iPhone is kind of a secondary UI. It's not a primary way to interact with your phone. I mean, there's some apps like text messaging app that's primarily entering things, but even there, people are, abbreviating everything, and they get the magic thumbs going and trying to make people type things into your program is usually a secondary kind of UI, and you want to think of another way to do it first if you can. Give them a list of common choices or something that they can scroll through and just hit it, just because it's hard to type on a little iPhone. Now, if you're building an app for the iPad, not so much true. On an iPad, the keyboard that comes up, especially in landscape mode, is pretty full-sized. So it's not so unreasonable that you'd think, text field would be more of a primary UI element. When you're building your application and you're using a text field, don't be fooled by the experience of your application in the simulator. Because in the simulator, you can type on the real keyboard and all of a sudden, woo, text fields are really easy to use. Then you run your app on the device and you're like, tiny little, especially like me, I don't have the magic text messaging thumbs going, so it's like everything is really hard to type. So don't be fooled there. So what about the keyboard? So the keyboard that zooms up from the bottom automatically appears when the text field becomes what's called the first responder, in a window. And this happens all automatically. There's nothing you have to do. And in fact, really I don't want to say there's no other way to get the keyboard to come up, but using text field or text view or the web view is the way to make the keyboard come up. Okay. Now in 4.0, iOS 4.0, there's some nice features for enhancing the keyboard or even replacing what comes up as the input view. But primarily, you're going to put a text field up, it's going to become first responder, and the keyboard's going to come up. So that's what we're going to talk about today, is that simple paradigm. So the text field now is on screen. It's got the blinking cursor in there. The keyboard comes up, and the user types something in. How do you get the text out? How do you find out what they typed? And the answer is through a delegate method, or delegate methods. UI text field has a delegate. And two of the key ones here are text field should return, which returns a bool. That's when the user taps on the return key, which is the key in the lower right-hand corner of the keyboard, which can actually have different words on it besides return. It could be like go or done or other things, and we'll talk about that in a second. But when you click that, you get this sent, and if this thing returns no, then it'll keep being first responder, keep blinking, keyboard won't go away, etc. If this returns yes, then it will. But you can even look at, you notice that this is a delegate method, and the sending text field is there as an argument. You could look at the text too. So for example, in the demo today, I'm going to make it so my text field won't let you hit return if there's nothing in the text field. In other words, I'm going to make you type at least one character. And I'm going to show just as something to do, show you how you can use the should return. And then text field did end editing. That gets called when the text field stops being first responder. In other words, it no longer has the blinking caret, the keyboard goes away, it calls that message. That's usually where you pull the text out that the user typed in and go do something with it. Okay? And there are some other text delegate methods, but these are the main ones. Again, text field API looks a lot like label, so it's got this property text. That's how you get the text out of it. So the keyboard, when the keyboard comes up, how do you control what it looks like? Because you've probably seen on the iPhone and on the iPad, some keyboards look different than others. And there are quite a number of what are called text input traits that control how the keyboard looks and acts. And so I put some examples here, like auto capitalization. If you, for example, set the text input trait called auto capitalization type, if you set it to UI text auto capitalization type words, which we're going to do in the demo, then as the user types, every time they get to a new word, it'll capitalize that word. Okay? And it can also do sentences, it can do no capitalization, etc. So there's also autocorrection. You've probably noticed that on the iPhone. That's the thing whereby when you start typing a word, it's kind of looking up in a dictionary type thing, what words might be right, and it actually, believe it or not, makes keys that are likely next touches larger. It makes their hit test larger. You don't notice that, but it is actually doing that, so you're less likely to click on the wrong thing. So you can control the autocorrection here, whether you want it off, you might not want it on at all. Like maybe you're typing in something like a name or something where it's less likely to know it's, random letters as far as it's concerned, versus when you're typing real words, you probably want autocorrection on. The return key type, there's a lot of different ones here. even like Google, you can have the Google return key copy, and it'll say Google on the little button. That just controls what it says on that button. Secure text entry is if you're entering a password. So some of you, I know for your final project, are doing something where there's like a user, and so you probably want to be able to have secure text entry. It just puts dots or stars when you're typing. And then the keyboard type can control the entire look of the keyboard. So like, do you want an ASCII keyboard? You want a keyboard for typing a URL? So maybe it probably has a slash on the top level of the keyboard instead of being a shift thing. Might have .com, things like that. Phone pad even for typing a phone number. Okay, so take a look at those text input traits. You set them by the text field implements that protocol, so you can set them directly on the text field, right? So text field dot autocorrection type or whatever. One thing to think about the keyboard, when it comes up, it covers up views. Okay, it doesn't move things out of the way, it covers them up. So now, I told you already, one thing what UI Table View Controller does is it moves the table up, if necessary, the rows up, to keep an editable thing visible. But if you have some other view, something you're doing, either you got to put your editable views at the top so that when the keyboard comes up, it doesn't cover them, or when that keyboard comes up, you got to move your views to be visible so they're not covered. Okay? Or even if it's not the view you're editing, but some other view that the user needs to be looking at while they're typing in the editable field, you might have to move things up. It's better to design your UI so you're really not moving these things up. But if you need to, you do it with NS notification. We haven't covered NS notification this time. You can look in the documentation. It's basically a way you send a message to this NS notification default center saying, hey, I'm interested when this particular named thing happens. And so the named thing here is UI keyboard did show notification, and UI keyboard did hide notification, etc. And you ask when a certain object sends those out, and the object you're interested in is self.view.window in your view controller, right? So the window is the thing that sends these notifications out. And then when you get the notification, the argument to your selector that you provide there is an NS notification object, and one of the keys in there is user info, and it'll give you the information about where the keyboard appeared, where's the visible space, etc., and you can adjust to it. So hopefully you won't have to do that, but just in case. Text field has a bunch of other properties. I'm not going to waste time going through these things, like clearing when you first click, does it clear out the text, things like that. The text fields also have left and right overlays. You've probably seen these, like sometimes there's a little search button in some text fields, right, where you click it and you can search by that thing, or so you can add little things. It's kind of advanced functionality. I'm not going to go into all the detail, but I just want to let you know these things exist so you can look them up. Keyboards also have some customization. They have this thing called an input accessory view, which it'll add at the top of the keyboard. So you might have a toolbar or something that adds keys to your keyboard or special function keys or whatever. You can do that as well. UI text view, as opposed to UI text field, is for multi-line scrolling text. Okay, so a text field is kind of for one-liners. You're going to hit return or go or Google or whatever, and it's going to you're going to get the text from the delegate and go. UI text view is you got a whole bunch of text, like a document sort of, but this is not like UI web view where you can have multiple fonts and images and all that stuff in there. UI text view is no images, all the same font. You can set the font, but it's all the same font. So it's, for simple displays of text that aren't too long and don't have a lot of formatting, etc. If you want the formatting and stuff, then UI web view, which we already talked about, is what you want. It has a delegate as well, UI text view delegate. It'll tell you about same thing as like UI text field. It'll also let you prevent changes. So if the user selects a range and tries to type something new in that range, your delegate can get involved and not allow it. UI text view is a UI scroll view, right? It inherits from UI scroll view, so all the scroll view methods work to scroll it. And it also has its own special scrolling thing called scroll range to visible, where you specify a range of the text and it'll scroll to make that, minimally scroll to make those characters visible. All right. Before I do a demo of text field, I'm going to combine it with modal view controllers. So modal view controllers is a way to put a view controller's view on the screen but it blocks everything that's happening in your app. It usually fills the whole screen, although not on an iPad, and we'll talk about that. But it blocks what's going on in the main running of your application in terms of its UI, waiting for the user to provide some input. So here I'm going to click a button here, and this is going to actually be a little movie, a little animation of a modal view coming up. I'll do it twice because it goes by pretty quick. So let's look at the one on the left. The one on the left is the alarm app. So this animation is going to click that plus in the upper right-hand corner, which is going to add a new alarm. Okay, so watch what happens. See, click plus, a modal view comes up. You can't do anything except for what that says. And then you click OK or cancel. Now you're back to your UI. Does that make sense? I'll do that one more time. So you plus, modal view is up. It blocks the entire UI. When you cancel, it goes back, and you're back to your. So you know, it even covered the. If you notice, it covers the tab bar even. See, you can't do tab bar. You can't do anything in your app until you answer that question. So, and then here's another one over here. This is the text messages app, and here it's going to put up a modal view to let you edit or create a new text message. So see, it clicks there, brings it up, and then it's bringing another modal view up to let you pick a address to send your text message to, and then goes back. So you can even have modal views on top of modal views. But the point about modal is it blocks, right? It's only, when the modal view is up, you can only interact with the modal view until you cancel it or otherwise make it go away. Everyone got that? Okay. And this is just another way to put a view controller's view on screen. It's just a particular paradigm for doing that. So how does this work? What does the code for this look like? There's a special method in View Controller called present modal view controller. Okay? And you call this, a view controller calls it on itself usually. And what it's saying is, take this other view controller and present its view on top of me modally. Okay? So, for example, in the clock one, when you press plus, the clock view controller would say, present modal view controller, and the argument it would pass would be the modal view controller that lets you enter a new alarm clock entry. You see? So I've got an example here where I have a method called lookup address in my view controller, and it creates this other view controller called an address lookup view controller, and it presents it modally on top of itself, and then it releases it. Now, what's a little funky here for people to understand what's going on is that when it presents it modally, it's not like the code in the other view controller stops. Okay, it just continues on nicely. Of course, it's hidden because it's behind the modal one, so if it was doing anything, no one would be able to see it. And in fact, it continues here to release that view controller, which is fine because I already passed it to present modal view controller, so it's going to retain it, and goes on its merry way. Okay, so now the modal view controller is up. When does it all end? Okay, when does my modal view controller come back? Okay, when does it go away so that my original view controller can keep doing UI? And the answer is this method dismiss modal view controller animated gets sent to the view controller that puts the other one up. Okay, you don't send this to the modal view controller that's on screen. You send it to the one that put it up. So the same object you send present modal view controller to is the same one you send dismiss. Okay? That makes sense? Now, an important thing, so you don't send this, in this case, to ALVC, the thing we're presenting modally. You send it to the thing that sent that. Also notice here, though, that address lookup view controller, the thing that's up there modally, it should not send dismiss to the other one. Okay? Now, if you learned anything about modal view controller, you know that when you push a view controller, or when you present it modally in this case, it really shouldn't have a back pointer to the guy who's pushing it. It should get loaded up with whatever information it needs, and it just goes and runs. Okay? But we've got a little bit of a conundrum here, because you put this modal thing up, maybe it gets an address, looks up an address for you. How do I get the information back if I can't talk to that thing? And the answer is delegation. Okay? So what you're going to do is the modal view controllers always have a delegate. Okay? And that delegate is always going to have a method that it sends when the modal view controller is dismissed. Either it might get canceled, so it might have one delegate method for that, or it does what it does, the user clicks OK, or does something that does what this modal view controller does, in which case the delegate is going to send a message, in which case the modal view controller is going to send a message to its delegate saying, here's what I did, or here's what the user did with me on screen. So then, obviously, the view controller that's presenting it will set itself as the delegate, right? And so when the modal view controller guy is done, sends a message back. And for example, here is a sample delegate method for address lookup view controller that I made up called address lookup view controller did select address, because that's what this modal view controller does. And so this will get sent back to the view controller that presented it because it's going to be set as delegate. And here's where the dismiss modal view controller animated yes happens. Okay? And when that dismiss happens, that modal view controller will be removed from the screen and released. So if you don't want it released there, you better keep a pointer and not do the release up above. See where I say ALBC release? Better save that release for later. If you don't want this, after this happens, it's going to be fully released. Okay, so be careful there. So notice that when I say do something with the address the user selected, I'm doing that before I do dismiss. See why I'm doing that? Now, if I, for some reason, couldn't do it in that order or something like that, then I would have to put that ALBC release down lower, which it's not that hard because notice the argument to the delegate method, we usually include the sender, right? When we do a delegate method, we usually include the sender. So you'll have the sender. You could release it here if you wanted. Okay. So how about how does the modal view controller appear on screen? You notice in the demo there it kind of slid up from the bottom. Well, there's actually different ways that it can come on screen. The default is to come up from the bottom. That's called cover vertical because it covers it and it slides up vertically. There's also flip horizontal, which will, whatever the view controller that's presenting it is on screen, it'll get flipped over and the modal one will appear. So that's kind of a fun one. It can also fade out. Fade out. The current view will fade out as the modal one fades in. Okay? And then this partial curl, it sounds fun, ooh, curling, but there's some restrictions on the partial curl, so check the doc on that. You want to be careful about that. Now, what about iPad? Okay, on iPad, we don't want the whole screen covered up with a gigantic modal view controller usually. We just want a, a little small popover or something. And in fact, there's another property here called modal presentation style, which you can set. You set this on the modal view controller. And so you might set it, for example, to page sheet or form sheet. Page sheet brings it up at kind of portrait width. So if you're in portrait, it fills the whole width. But if you're landscape, it only fills a portrait size width, and the rest is kind of dimmed. The background is kind of dimmed and not accessible. Or there's even form sheet where it'll just come up in the center, at whatever size you want. It's still modal, right? It's still coming up and blocking the thing behind, but it may not cover it entirely, in which case it automatically kind of dims it in the background. So you can play with these on the iPad and see how these various presentation styles work. Okay, so the demo I'm going to do here is a new app. It's called Label Mover, and we're going to use it as the substrate to do the next few demos. Well, the label mover is really simple. It just has a view controller that has a label in the middle. All right? And what we're going to do in the first part is we're going to make it so that if you swipe on this view controller, it's going to put up a modal view controller that has a text field in it that lets you type the text that's in the label. Okay? So that way we'll show you text field and modal view controller all at once. All right? So let's do that. So let's go here. We're going to create a new project. This time I am going to create a view-based project so that I get, a view controller for myself. I'm going to call it Label Mover. You'll see why I call Label Mover in a future demo. In case you guys haven't been doing view-based projects for a while, this is going to be some review, which will be nice also. But you can see that it created this Label Mover view controller for me, including a zip file for it. So the first thing I'm going to do here is just create an IB outlet for the label and create my nib file that has the label in it. It's just a label in the center of the screen, that's all. So I'm going to here IB outlet UI label I'm going to call it my label. And then I need a property, retain, IB outlet, UI label, my label. Okay, so that's my label. Let's go over here to our implementation and just synthesize this label. And to be a good citizen, I'll go down here and do self.mylabel equals nil. And I'll even go down here and say my label release. Okay, so that's just normal stuff when you add an outlet, memory management, all that stuff. So let's go to our zip file here, and you can see that it's blank. I'm actually going to set it to be the default color, which is white instead of gray. And then I'm just going to drag this label out here, set the font maybe to, 36, 24, 36, let's say. So we'll just start with it in the middle. Let's go ahead and connect it up. My label, save, quit. Go back to Xcode and run. Okay, so I haven't really done anything here that shouldn't be, by this point, completely straightforward and obvious to you. I just created this label. It doesn't do anything yet. So what we're going to do is make it so that if I swipe, it's going to put up this modal view controller. So the first thing we want to do if we want to put up another view controller is we got to invent this view controller. So let's go do that. We invent view controllers here with new file, view controller subclass. It's not going to be a table view. I am going to have a zip file for it because I'm going to have a little text field and label in there. I'm going to call it Asker View Controller. That's because what this view controller does is it asks a question and gets an answer. And that's all it does. It gets very generic. Again, usually when we're building views, we want them to be generic. I don't want this to have anything to do with label mover, or whatever. I'm just going to have a general view controller that asks a question, gets an answer, and returns it, okay? So I'm going to clean up this, put this up here, like that. So what do I need in terms of model and view for my controller here? And the way I'm going to do this, I'm going to have my model essentially be the question to ask, okay, and we'll let the user set this question. This will be the question that my asker is going to ask. And then I need some outlets here. I need a label, which is going to be my question label. And then I'm going to have a UI text field, which I barely need to have an outlet for, but we'll call that my answer field. And then I'm going to have a property copy, which is the question. So we'll just let people set the question. We'll copy it. Remember, NS strings we tend to copy because it's cheap to copy. It's like retain, but it would turn a mutable string into an immutable one, which is nice because I wouldn't want someone to set the question, change the mutable string underneath, and then I'm supposed to somehow figure out how to change my question label to have that new thing. That would be very difficult. So here, that way, it's clear to the caller, I'm going to copy this thing. In other words, the question that's asked is the question when you set this. So now let's have our two IB outlets. Notice I'm making these public. Okay, we've talked about should your IB outlets be public. Sometimes yes, sometimes no. This one I'm going to allow these to be public because if someone really wants to go in there and set some attribute of the question label or of my answer text field, I'm going to let them do it. And it's a design decision. Oops, answer field. It's a design decision, and since this is a very simple view controller that just asks this question, then I'm willing to let people muck about in there. If I was doing more complicated things between the question label and the answer field, and I was trying to keep them in sync, and all, then I might not have someone in there, messing me up. But here I'm going to do that. So let's go over to our view controller. Let's synthesize our question. So we get set our getter there, and let's synthesize our question label and our answer field. Again, let's do our memory management here. Self.question label equals nil, and self.answer field equals nil. And we'll even dealloc here, which is question release, question label release, and answer. I'm doing this all just because I want to make sure you guys have a little bit of review. Make sure because we haven't done IB stuff for a while. We've been doing table views and stuff. So just thought I'd type that in there and make sure you get that. So So let's start with kind of the bare bones of what my Asker view controller is going to do, which is when it appears, it's going to set the question in the question label to be the question. Okay, so let's just do that. So that's view will appear, call super, and then I'm just going to say question label dot text equals my question. I'm actually going to set the answer field's text to nil. Okay, so I'm going to clear out anything that's in there. And then the other interesting thing I'm going to do here is I'm going to make the text field have the blinking cursor. Okay? In other words, when I appear on screen, I want to immediately be editing. I want the keyboard up and the thing editing. I don't want the user to have to click on there or touch the field. Do you understand what I'm saying? What I want to do here? So how do I do that? Well, I do self answer field become first responder. Okay, because I told you that the text field that is the first responder is the one that has the blinking caret. I should probably be doing self here just to be nice. Okay, in case there's overriders or whatever. So I think that is all I really wanted to do there, yes. Okay, yes, let's put our synthesize inside implementation context. There we go. Okay, so the next thing I'm going to do is the text field delegate, all right? Because I've made it so that when I appear, I put my question in the question label and I clear out the answer field. But right now, nobody is the text field's delegate, so no one's ever going to find out what anyone types in that text field. So how do I do that? Very straightforward again. I go over here, UI text field delegate. Okay, I'm going to make this is the Asker view controller. It's going to be the text field's delegate. And I'm going to implement a couple of the text field delegate methods. I told you I would do bool text field should return. And so again, I'm not going to allow the person to hit return, confirm the input if it's blank. So I'm just going to say if text field dot text dot length. Okay. Then I'll return, yeah, sure. Else, I'm going to return no. Okay? Now, there's one other thing that usually I want to do in should return, which is that if I'm allowing the return, I want the keyboard to go away. So if the user touching that return button or the Google or the Go button, I want the keyboard to go away. So how do I do that? Exact opposite of what we just did above. I say self, or I could even do it here, text field, resign first responder. Okay? So become first responder is how you tell an object to become the first responder, and resign first responder is how you tell it to stop. Okay? And if you don't explicitly tell it to do that, whatever object happens to be first responder will just keep being first responder forever. And if nothing's first responder, then no keyboard will be coming up. And then the other one is text field did end editing. So this gets called when it resigns first responder conveniently. And so here I'll just log for now. Let's just say text is %@ text field dot text. Okay, but obviously, really, we want our modal view controller here to cause its delegate to get fired up. But so we'll do that in a second. One other thing we have to do here is that our view controller is not the delegate of our text field. We need to set it to be the delegate of our text field. Now, we could actually do that in Interface Builder, turns out, right? If we go back to Interface Builder and we look at, sorry, wrong one. Well, we haven't done Interface Builder yet, but so we could do it when we do our Interface Builder piece of this. We could do it there, or we could do it, for example, in View Did Load. So I'm just going to do it in View Did Load here, just so it's not a little bit hidden. Sometimes Interface Builder, it's hard to remember what's going on. But I'm just going to say answer field delegate equals self. Here's also where I might say answer field dot, auto capitalization type equals UI text input trait or text, what's it called? Auto capitalization type words, for example. Okay, so this is where we might configure our text field. This is View Did Load, our typical place. All right, so that's kind of the code for this view controller. Let's go build the user interface for it. We go to Ask Your View Controller here in Interface Builder. And, of course, we have a label, which I'm going to put at the top here. I'll make it, the whole width. Let's make it larger also. Let's say 24 point. Looks pretty good. And then we need a text field. So it's, dragged out just like anything else in Interface Builder. We'll put it right here. Make it also wide. Let's set its font to be 24 point. And that's pretty much it. So this is the entire UI to my controller. So let's wire up our outlets. So here's our answer fields. I'm just holding down Control and dragging here. And there's our question label. Okay, so there's that. So that's it. Ask Your View Controller. We have a view controller. In fact, let's go ahead and put this thing on screen. It's still not going to work because we have no way to dismiss it because it has no delegate yet. It's not sending a delegate. But I just it's kind of there enough so we can see how this would work. So remember I said we're going to put this up with a swipe gesture. So let's go ahead and set that up. I'm just going to say view did, this is a reminder how to do these gestures. View did load. I'm going to say UI swipe gesture recognizer. Thank you again for Xcode for typing this one. Swipe gr equals UI swipe gesture recognizer alloc. And you'll remember that gesture recognizers take a target, which is going to be self, and an action, which I'm going to say this one is selector swipe. Oops. Yeah. Oops. When you do too many square brackets, you pay. Okay. So there's the swipe. I'm going to add that to self.view. Remember, that's how we add gesture recognizers. Swipe gr. So now my self.view, which is just my top level view in my view controller, it has a gesture recognizer. It's going to recognize swipe. It's going to call swipe on myself, because I set my target right here to be self. I'm in the view controller here. And then I need to swipe gr release, okay, because I'm done with it. I added it as a gesture recognizer. I don't need it anymore. So what does swipe do? Void swipe, here it is. All right. So it's just going to create an Ask Your View controller, so we better import that. All right.
Don't you need a colon after swipe?
No. So the question is, do I need a colon here? And the answer is no. Gesture recognizers, you can have a colon or not a colon. Since a swipe, I don't need to know anything about where the swipe was or anything. I'm taking any swipe. I don't need the argument of the gesture recognizer. Okay? So I'm just going to set my target there to be swipe. You can put a colon if you want, and if you put a colon, then your gesture recognizer will get called with the gesture as the argument. Okay? But I don't need it, so I'm not going to do it. I'm not going to have it. So here's my asker, and I'm just going to say asker view controller alloc init. It's just a view controller. I'm just allocing it. I'm going to set the question to be, who are you? Okay, it could be any question here. But we're going to say, who are you? And that's what's going to be my label. Then I just say self present modal view controller. Self space. Present modal view controller. Asker, animated. Sure. And then asker release. All right. So if we've done this all right, hopefully this will work in terms of putting up when I swipe. Voila. Okay, we have this modal view controller. It comes up. It's blocking my UI. I can't do anything back in my label UI, and it's asking. And if I try to hit return here, see, it doesn't work because I had that should return, and I only am allowing it if I type something. So if I type, CS1, oops, not CA, let's say CS, oops. See, this is giving an example. It's more difficult to type than it seems when you're doing it this way. Now, I could be typing on the keyboard, but just as a matter of practice, I don't do that when I'm programming, just so that I get the experience the user is going to get. So I say CS193P. Now, I hit return. It stopped being first responder, put the keyboard away, and now I'm stuck. Okay, I could click and keep editing, but I can't get back. And that's, again, now we have to implement the delegate piece of this. Okay, where the Ask Your View controller is going to have a delegate. It's going to tell it the answer it got. So let's go ahead and do that part. So The Asker view controller delegate is just going to be an instance variable. So ID, we'll call it the Asker view controller delegate, and we want to definitely have a property for that, and it's assigned. Remember, we make delegates to be assigned. This should harken back to your calculator view, your calculator graph view. It takes an ID, which is an Asker view controller delegate. All right, so there's that. And now we need to define the delegate protocol. So I'm going to say protocol Asker view controller delegate, and I'm only going to have one method in my delegate because there's no way to cancel my thing. You have to have answered the question properly. So I'm going to say void Asker view controller sender did ask question NS string question and got answer NS string star answer. Okay, so can you see why this would be a good delegate protocol for our view controller? Because that's what our view controller does. It asks a question and gets an answer. So I'm going to have the delegate method say, hey, I'm an Asker view controller. I asked this question and I got this answer. Now you could argue, why do you need to send the question? Because the person knows it already. But it's just convenience. Why not? Make it life as easy as you can on your delegate. Give it the question back. We have one other problem here, though, which is that this symbol is not defined at this point in this header file. It's not defined till down here. So if we try to compile it, it won't work. So I need to do what's called a forward declaration. Hopefully you remember this from your graphic calculator. So I'm just going to say Asker view controller delegate is a protocol. That's all I'm saying at this point. The compiler can't resolve what kind of protocol it is, but it knows that it is a protocol. And so when I compile, it won't fail. Now I have a couple of warnings here. I can tell you what those are, which is that I need to synthesize my delegate here. All right, so I have a setter and a getter for the delegate. And when do we send the delegate method? Well, we send the delegate method when the editing ends in that text field, right? So that's this text field did end editing, that we already have this log in here. So I'm going to get rid of the log, and I'm just going to say self.delegate, Asker view controller self, did ask question label dot text. I could maybe say question there, but I kind of like doing question label dot text in case some nosy user of this went and did something to the text label, its question label itself. And this is answer field dot text, and I could also say sender dot text here as well. So that's it, right? And we don't need this. Okay, so now we have this. All we have to do is have our label mover view controller set itself as the delegate before it presents that thing modally, right? So that's over here. Here's where it presents it modally. So it also needs to say asker.delegate equals self. Now, if it's going to be the delegate, it has to implement that method. So we go out to here, Asker controller delegate. Oops, color, yeah. Okay, and then let's implement that method. Let's make life easy on ourselves. Copy and paste. There's the method. Okay, what are we going to do when we get this delegate method? We're just going to set our labels text to be the answer that we got. Does that make sense? All right, cool. So let's do that. That is self.mylabel.text equals the answer. I'm going to do something here where I'm going to take the label and size it to fit my answer, but I'm going to do it in a way where the center of the label doesn't change. So I'm going to just keep track of the center of the label. I'm going to call that label center equals self.mylabel.center. Then I'm going to say self.mylabel.center size to fit, which is a method in view, which is kind of an interesting method. Subclasses override it to size the frame of the view to fit the contents in a nice way. It doesn't make sense for all views, but for labels it makes a lot of sense. And then I'm going to say self.mylabel.center equals that saved label center, so that because resizing it might change the frame, and now my center got moved, so I want to keep that thing in the same thing. And then last, let's do self dismiss modal. Sorry. self, dismiss, modal view controller, animated, yes. Okay, what did I do here? Sorry, center label. Okay, right, sides fit the label. Okay, so now everything should be good, right? We create our modal view controller, we set ourselves as the delegate, we present it modally. When it's done with the text, it sends us a delegate method, which is this thing right here. We update our labels text, resize and position ourselves, and we get rid of that modal view controller. So let's see if this all works. Okay, so here's our label. I'm swiping. Again, let's go C, S, 1, 9, oops, 9. This is just like typing in real life on these things. P, there we go. And it changed our label. Okay, and it dismissed the modal view controller. Okay? Everyone understand that? So modal view controllers, a lot of you are going to use modal view controllers in your final project because you're going to want to ask the user a question or something like that, and you're just going to put that up, ask the question, and then continue on. Okay? Any questions about that? About text field or modal view controller? No? Okay, so let's go on to our next thing, which is view animation. UI view animation. So what is this about? So I told you there are certain things you could animate when you change them in a view or when you change things in the view hierarchy. So here are kind of the main ones that you can animate. The view hierarchy itself, adding or removing views, and the hiddenness too, whether something's hidden or not. Also the frame. So if you move the view around or change its size or something like that, that can be animated. A big one is the transform on the view. I told you that all views have this affine transform, which is a translation, rotation, and a scale. So you could scale the view up bigger, okay, and have that animated, all right? Or you could move the thing around, or you could rotate even the view and have it animated. And then also alpha. Okay, this is a kind of a cool one too. You can animate the overall opacity of your view. So your view can be drawn with alpha and different opacities inside of it, but also the overall opacity, there's this property alpha on a view that you can be used to like make a view fade out or fade back in. Okay? So how do we do this? And the answer is it's done with a UI view class method, actually a few UI view class methods, and blocks. Okay? So now that you've learned blocks, I can show you how to do this. The arguments to this class method are basically some options about how you want the animation to happen, and then a block which is just changing these attributes in the view. Setting the alpha, setting the transform, modifying the frame, whatever you do it in the block, and whatever you're doing there will get animated. All right, simple as that. It also takes a second block, these methods, which is a block of code to run when it's done animating. All right, so maybe it takes 3 seconds to animate this thing. When it's done, it'll run another block of code for you, which is kind of convenient. This whole thing is built on top. Oh, sorry, one thing. Yeah, okay. There's an important line there. See, it says the changes inside the block are made immediately. This is important to notice. Okay, the block that's being animated, like you're saying alpha equals 0.5 to make this thing half transparent. When you do the animation, call the animation class function, that happens immediately. Okay? So that alpha happens immediately. Now, the drawing of it is going to be animated. So it's going to take 3 seconds. But when you said inside the block that you passed to that view animation method, set the alpha to 0.5, that immediately returns, because all these animations are done in a thread, that immediately returns, and from that point, immediately, alpha will be 0.5. So what you do in that block happens immediately. Now the completion doesn't. The completion happens later when the animation's done. But the main block that you're implementing happens immediately. And that's really sometimes hard for people to understand. They're watching their view being animated across the screen, and they're thinking maybe alpha is changing as it animates, or alpha won't change until it's done animating. No. The instant you say to animate it, it makes the change. Again, it's only the display of it that's being animated. All right? Yeah, so core animation this is built on. You can look at core animation. Way too much to cover in this class, but that's the fundamental framework this is built on. So here's the class method, okay? Here's the main class method. Animate with duration. So that's how long it's going to take for this duration to happen. Delay, which is how long, these are in seconds, how long you're going to wait until you start the animation. again, the block is going to happen immediately. There's no waiting, okay? But this is how long it's going to wait till it shows the change happening. Options, we'll talk about options in a second. There's a lot of options for how to do the animation. And then animations : a block. And that's the block. Inside that block, you change these things like hidden and alpha and transform to whatever you want. And it'll animate the view's current state to that, whatever it would look like after you applied all those things. Now, and then there's completion block too. We'll talk about why that takes a bool in a second. But how does this all work? So the way this works is your view is currently on screen. It's got, the iOS basically has an image of it. When you set all these attributes, it just immediately gets your view to draw again. Okay? But it's drawing off screen. And then it's just animating the differences between these two graphical states, basically. And core animation is really smart about intermediate steps it needs to take to animate it, all those things. But this is all happening off-screen threads. They're just, the images are just being blitted to the screen, transferred to the screen. So it's all happening behind the scenes. Really nothing you need to know specifically about how it happens, okay? So here's an example of calling this thing. So here I have an animation. It's going to take 3 seconds, and it's going to start right away. Notice I'm giving this option, UI view animation option, begin from current state. What that means is, if I've started this animation and some other animation is already in progress, then whatever the current state, partial state of the world that animation is in, that's where my animation is going to start. So let's say I have an animation that moves a label across the screen. If I click to move it somewhere else, the label will start moving from where it was. In other words, it won't jump to the end, which is where it really is, and then start animating down. The animations will link, basically. You'll see that when we do the demo. And this particular animation is just setting the alpha to 0. In other words, make my view completely fade out to nothing, to not being visible in 3 seconds. Notice that I also have a completion block there that says, if my animation ran to completion, which means no other animation about alpha ran in that 3 seconds and took over, then remove my view from the super view completely. So what this line of code does is it animates the fading out of a view over 3 seconds, and at the end of the 3 seconds, if it makes it before the fading gets animated by some other call to this method, then it removes it from super view. Okay? This is a kind of a good example to understand the timing. The fact that as soon as I call this method, alpha is going to be 0. But a second later, I might animate alpha to be 0.5. All right? And as soon as I do that, this one's going to get interrupted. And it's going to start going towards 0.5 instead. Okay? So you could have multiple animations going, and they can interrupt each other or not, based on this UI animation option to begin from current state. So here's another example. This one I just changed the delay to 2 seconds. I just wanted to make it clear here that even though I have a delay of 2 seconds and a duration of 3 seconds, if I run this code, it's going to say alpha equals 0. Right? Immediately. Because inside the animation block, I'm saying myView.alpha equals 0. That happens immediately. Even though on screen, nothing's going to happen for 2 seconds, and then it's going to take 3 seconds for alpha to go to 0. Okay? Really important to understand what's going on there. The whole animation stuff is happening in another thread. Think of the animations as just displaying the change you just instantly made to the user over time. Okay? That's what's going on with these animations. So let's just do a demo. I think this will make a lot more sense when we do the demo. So what we're going to do in the demo is we're going to make it so that when I tap on the screen, the label animates moving over to that place I just tapped. It's going to kind of slowly move over there. So first, I'm just going to add a new gesture recognizer, which is a tap. And so I'm just going to have well, first let's do that. So I got a tap gesture recognizer, tap GR, UI tap gesture recognizer alloc, init with target, self, action. Now this action, I do want the tap gesture because I need to know where the tap is. So here I'm going to call this tap : not just tap like I did with swipe up there. Does that make sense? Why doing it with that? And then self.view, add gesture recognizer, tap gesture, and then tap gesture recognizer release. Okay, so that adds our tap gesture recognizer. Here's what it looks like. Tap takes a UI tap gesture recognizer. I don't know why it's not typing that for me. Gesture. I'm sure I'm not forgetting anything here. Yes. Okay. So all I'm going to do here, actually I'm going to have a little method because I know I'm going to be animating this. So I'm going to have a method called self move label. I'm going to take my label as an argument, to point, and I'm going to move it to where the gesture happened. View self.view. Okay. So okay, so I have to implement that. So let's do that. Void move label takes a UI label. You might ask, why am I taking this argument? Because I might have multiple labels in a future demo. So we'll call that label. Point, CG point, P. Okay, so if I didn't have animation, this would just look like this. Label.center equals P. So let's just run this without animation, see what that's going to look like. Okay, so I click it, just jumps to where I clicked, right? Everyone understand that? All right, just added a tap gesture. Wherever the tap gesture is, I move the center of the label there. But what we want to do is when I click, I want it to animate. I want it to take a couple seconds to move over there. So how would we do that? So all we need to do is say UI view. It's a class method, okay? This animate thing is a class method. Animate with duration. Okay, I'm going to take 2 seconds. I'm going to use the version that specifies everything. So delay 0. So I'm not going to wait. I'm going to start doing it immediately. Options. Okay, I'm going to set the options here in a second. Animations. So this is what I need to animate, which is just what we want to change, which is that. And then completion. And I'm not going to have a completion handler. Okay, I'm not going to do anything when it completes. So I can just say nil. Now, what about these options right here? These are UI view animation. View animation options. Is that what it's called? I never remember what these are called. View animation options. Yes, options. And the two I want here, I want the thing where if I click again while the thing is moving, I want it to start animating towards the new place in the middle. So I'm doing this intentionally because I want you to understand what this means. So this is the UI view animation begin from current state. Is that what it's called? View animation option begin from current state. The other one I need to set is UI view animation option allow user interaction, because I want to be able to do more tap gestures in the middle of animation. You could imagine what you had an animation happen. You don't want the user tapping or swiping or something in the middle of that because it might be important for it, to look good or whatever. So the default is that all the tap gestures and all these gesture recognizers are disabled while the animation is happening. But I don't want that because I'm going to allow myself to click and change the path of it. And so that's it. That's all that's required to do this. So let's take a look. All right, so now when I click, you can see that it moves. Notice it's also it starts off a little slow, and then speeds up a little, and then it slows down. That's called easing in and easing out, okay? And you can specify that behavior. Do you want to ease into its motion and then just finish it? Or ease in, go, and then ease out? Or start immediately at full speed and then ease into its final location? You can set all those things. But now watch this. So here I'm clicking it. Now watch if I click again. You see how it stopped in the middle of the animation and started going towards the new place? Okay, you see that? So that's what this thing of, even though the instant I call this, the label center is set to be the new location, even though it didn't jump there, but it is there. But the animation engine knows how, if you click in the middle of the animation, to interpolate where the center would be at that point and then start moving from there, so that you don't get these jerky, jumpy animations. Yeah. So the question is, would I use view animation to do games? And the answer is yes and no. Probably not at this level, but you definitely might use core animation, which is the level below. Core animation is about I've got some images or some attributes that are changing over time, and I want to animate them smoothly. That's what core animation is about. So that layer, yeah, you might use that layer indeed. But up at this layer, likely not. It depends on how fast interaction your game is. You know, how many different images are moving and all that stuff. So anyway, so that's it. We have 30 minutes, so I'm going to show you a little more on the animation. What if, in addition to moving, I want my label to kind of rotate? I'm going to have it rotate and then rotate back. Yeah. Oh, question. Sorry. I can't see the light over there.
Is animation going to be as snappy on an actual phone as it is on the simulator?
Yeah. So the question is this animation of clicking around and having it do this going to be just as snappy as on a phone as it is in a simulator? This one, absolutely. Absolutely. In fact, next time when I do a demo, I'm going to do it on the phone, and you're going to see, sure. Because, this is very highly optimized code, this core animation layer, and it's using the graphics processor in the phone to really good effect. So yeah, it's definitely, you have this nice smooth animation just like this. It wouldn't be jerky or non-responsive or whatever. It's very good. So what I'm going to do, in addition to moving, I'm going to rotate. And the reason I want to show you this is the way you can do multiple animations at once is you can just issue multiple animation requests, because you got to remember these animate calls return immediately. They do the block and return immediately. All the animation is happening in a thread. So I can start another one, and it starts its own thread, and the two threads, they work together. Core animation does the right thing. It might be implementing it all in one thread. It's kind of up to core animation. You don't know what's under the covers. But conceptually, that's what's happening. So here, if I wanted to do rotation, let's animate with duration. I'm going to have the rotation go halfway the first second, and then back in the second second. So 1 second. Delay, none. Options, same options. I'm going to allow it to be interrupted, and I'm going to begin from whatever rotation state I'm in when I try to do somewhere else. And so this animation looks like this. We're just going to say label.transform. So here's how you set this affine transform. And I'm going to set it to CG affine transform rotate, and I'm going to rotate the identity transform to pi degrees. Okay, this takes radians. It rotates in radians. So that's going to rotate this thing pi degrees, halfway around a circle. Now, here's an interesting part of this. So that's the end of that. So how do I make it go halfway and then turn around and go back? Well, that's why I need these completion handlers. So when this thing is completed going halfway, then I'm going to have a new animation that goes back. So I say completion, and remember that the completion handler takes a bool. This bool is whether we got interrupted by some other animation being called. And inside this, I'm going to have yet another animation. So I'm going to go UI view, animate with duration, 1 second again, delay of 0, options the same, animations. And so now I'm going to say label.transform equals CG affine transform identity. So I'm just going to go back to normal. Okay, so the identity transform is no scaling rotation or whatever. And this one has no completion handler. Okay, so make sure I get all my things here matched up. I did. Okay, so people understand what's going on here? So hopefully this should make it a little clearer what's going on with these animations getting fired up. So hopefully now I click, you see, it's rotating and then rotating back. Okay? So both those animations are happening at the same time. The moving one is taking 2 seconds, and if I click halfway through, you see how both of them are continuing from any partial amount through. Okay? Got it? Okay, so that is all I'm going to do today. Next week, I'm going to talk about some more miscellaneous topics that you're probably going to need for your final project. Core motion. I'm going to do core motion, and we're going to actually put it on a device, and I'm going to show you how to use the accelerometer to move our label around by tilting our phone, okay, and moving our label around that way. I'll also be showing how to do alert views, okay, how to put up an alert on the screen. Timers, which timers can be good for doing simple animation that's just images overlapping. You just run a timer, have it go off at a periodic basis. So I'll be talking about essentially miscellany like that. I'm hoping one or more of the last lectures after that. There's only 3 lectures after the next lecture, and I'm hoping at least one of them will be a guest lecture. We'll get somebody from Apple or somewhere to come and talk in detail about some topic or other.
For more, please visit us at stanford.edu.